Hello and welcome again. Today we are going to discuss some questions, certain numerical questions based on wheatstone bridge. Okay, so uh, continuing with my previous topic of wheatstone bridge theory. So these four questions which I have chosen to discuss with you today, and the questions are very simple. Basically, you have to figure out in three of the questions out of four in three of the questions you have to just figure out that it's a wheatstone bridge. The moment you figure it out that it's a wheatstone bridge, your calculation becomes very simpler. The first question is wheatstone bridge only, but it has slightly this type of variation over here. Let us consider this as question number 1. So say that this is 10 ohm, this is 5 ohm, and here I am using a parallel connection over here. I am calling this as X ohm and this as 60 ohm, and this I am selecting as 10 ohm, and there is a resistance over here R0. Now the question is, what should be the value of X so that no current flows through the R0 resistance? Now if the condition says no current flows through the R0 resistance, that means we are looking for wheatstone bridge. So if I take this out, then the wheatstone bridge simply says that this by this must be equal to this by this, or you can say this by this equals to this by this. I generally prefer to take this one, this by this equals to this by this. You can take this by this equals to this by this. That is what P by Q equals to R by S. Now consider that this whole effective, just for a moment, consider that this whole effective is R dash, correct? So if I go by the formula P by Q, that is 10 by R dash is equal to this by this, that is equal to 5 by 10, or in the next step I can write this one as 10 by 5 equals to R dash by 10. So you can see the moment I interchange this one, it automatically follows this rule, this by this equals to this by this. So whichever way is possible is up to you. So from this implies what is R dash? R dash will be equal to 10 tens are 100 divided by 5, so you will get 100 by 5 and that will be equal to 20 ohm. That means this R dash, this whole thing must be 20 ohm. And what is this whole thing? This whole thing is a parallel connection of X and 60. So I will write here as X plus 1 by 60. And R dash we have found as 1 by 20. So 1 by 20 is equal to 1 by X plus 1 by 60. That is 1 by X is equal to 1 by 20 minus 1 by 60. The LCM is 60. This is 3 minus 1, that is 2 by 60. That is 1 by X. Therefore X will be equal to 60 by 2 and that is equal to 30 ohm. And hence we got the answer X equals to 30 ohm. This is question number 1. Question number 2. Now from here onwards you have to identify whether it's a wheatstone. It may not look like a wheatstone bridge. Remember, our wheatstone bridge looks like this. This is your end where your potential is connected, EMF is connected, and this is the resistance which generally goes out from the circuit. If this is P, Q and this is R, S, and you can write P by Q is equal to R by S, or P by R is equal to Q by S. Whichever way you wish to write, you can write. Okay, this is how our wheatstone bridge looks like. Okay, now the question which I am going to discuss now is like this. This is the question, and the question is, okay, let me put the value here. This is 5 ohm, this is 3 ohm, this is 2 ohm, this one is 4 ohm, and this one is 6 ohm. Now, if you are clever enough, if you have that imagination of geometry or that creativity in your mind, you can just think of like this. You take this A from here and you pull it out from here. Okay, So this is your A, and then you just pull it out and stretch it. You will automatically get a figure like this. Or, no issue, if you can't do that, just name it. Consider that this point is C, this point is D, and this point is, I'll go as per the note, C, D, and this is A. Okay. So this is my A junction. This is my A junction. Now what is happening here? You start writing from here. This is my A junction. Now from A, I reached here, and then two branches goes out. So two branches goes out. One is 2 ohm on that side, which goes to C, and one is 4 ohm, which goes on this direction, and this goes to point D, and this is point D. And now if you see very carefully, C and D are directly connected, and from C one goes as 3 ohm to B. So from C one goes as 3 ohm, so 1 ohm goes to 3 ohm to point B, and from B to D there is again one 6 ohm. So from B, this is also B. So from B to D there is one more resistance over here, and that is your 6 ohm. And you can see there is a direct connection between C to D, and that is 5 ohm. C to D. So this is my C to D, and this is my 5 ohm. And then C to B was 3 ohm. Now you can see here 2 by 3 is equal to 4 by 6, because 4 by 6 also has a ratio of 2 by 3. So this by this equals to this by this, or you can write 2 by 3, this by this equals to this by this, 4 by 6, or you can write the same thing, you can write as 2 by 4 is equal to 3 take here, 4 take here, 3 take here, and it comes 3 by 6. So 2 by 4 ratio is 1 by 2, 3 by 6 also the ratio is 1 by 2. So it is a wheatstone bridge, so this goes out. The moment this goes out, now this 2 ohm and this 3 ohm will be in series, and this 4 ohm and this 6 ohm will be also in series. So whatever current goes here will go here, I1. Whatever current goes here will go here as I2. So this 2 in series, this 2 in series. So that will give me my resistance effective circuit like this. This is my A, this is my B. So 2 plus 3 is 6, and 4 plus 6 is 10. And then we have to use the parallel method over here to find the R effective. So this becomes 1 by 6 plus 1 by 10. Okay. And then when you simplify this, 2 plus 3 is 5. This is 5, and this is also 5. And when you solve this, you should get the answer as 10 by 3 ohm. So your answer will be 10 by 3 ohm after solving it. Okay, so that's question number 2. So this is also a wheatstone bridge in this shape. Question number 3. This is my A, this is my B, and this is 2, 4, 3, 6. Now if I exclude this part for a moment, just exclude this part. This one, if you look very carefully, it's a wheatstone bridge again. With, if I consider that this point is C, then from C one goes as 2 ohm, one goes as 4 ohm. This is directly connected, and then this is your 3 and 6. So your 2 by 4 is equal to 3 by 6 because the ratio is 1 by 2, or 2 by 3 is also equal to 4 by 6 because the ratio is 2 by 3 when this ratio is 2 by 3. So I can say that this part is my wheatstone bridge. So if this is given as 5 ohm, but it will not be in the circuit as no current flows through that. So what will I get? I will get here as, so this 2 and 3 becomes in series, so it becomes 5 ohm. 4 and 6 comes out as 10, and then you have this as the 15 over here, which is also given to you. Now 5, 10 and 15, this is in your parallel connection. So 1 by 10 plus 1 by 5 plus 1 by 15. So if you do this, your LCM is 30. So this becomes 3 plus 6 plus 2. So that is your 1 by R. So R will be is equal to 30 divided by 11. So answer is 30 by 11 ohm. This is your answer. Question number 4. This is one of the most famous question of wheatstone bridge. Almost every book discusses about this question. Basically the shape of the question. The value of the resistance may differ from book to book. This is how it looks like. So this is my point A and this is my point B. And the resistances which are given as 2 ohm, 4 ohm, 5 ohm. This is your 3 ohm and this is your 3 ohm and this is your 6 ohm. Now how will you do this? Again, name it. The best thing you can do is the name it. So this is my point A. So if I go through this, I will get a potential drop. So let us say that this is C. From this will be your D and this is already B. Now see what is happening from the A. So from the A, this is your A. From A, one goes through 2 ohm to point C. So one goes to 2 ohm to point C. And from A, one goes to point D. So this is my 2 ohm. And the one which is going to point D is my 4 ohm. Okay? And there is a direct connection between C and D. So there is a direct connection between C and D, which is equal to 5 ohm. And then from D, there is one which goes to point B. So from D, there is one which goes to point B. So this is 6 ohm. This is my point B. And then from C, there is one more which is going to point B. This is C to B. So this is your from C to B. And this is your 3 ohm. And now if you look very carefully over here, 2 by 3 is equal to 4 by 6 because 4 by 6 also has a ratio of 2 by 3. Or 2 by 4 has a ratio of 1 by 2 and 3 by 6 also has a ratio of 1 by 2. So I can write here this by this by this is equal to this by this, and that is equal to ratio is 1 2 by 3. So this becomes 2 and this becomes 3. So both are equal. That means that proves that it's a wheatstone bridge. So no current flows through this. Once no current flows through this, then 2 and 3 is 5 and 6 and 4 is in series, that becomes 10. So I will again get the same result here as 5 ohm over here and this one as 10 ohm over here. And then the final answer will be the parallel connection of these two. So it is 1 by 5 plus 1 by 10. And here you will again get the answer as 10 by 3 ohm as your answer. You are not, ISC has one rule which you should know, that do not leave your answer in fraction. Okay, there is a rule by ISC. So you have to basically write this one as 3.33 ohm. Always put that in decimals. Okay, never leave your answer in terms of fraction. That's one of the rule of ISC. Okay, so that's it. The prep will be also uploaded. So do some questions more based on wheatstone bridge. And keep practicing. Thank you for watching.